In this lesson, we'll talk about inverse trig functions. We we have used them just with the calculator to find an angle, missing angle on a triangle. So let's look at them in a little more detail. We know that sine of pi over 6 equals a half. So that means that if we did inverse sine of sine, inverse sine of 1/2, then we would get pi over 6 equals inverse sine of 1/2. You can write it like that, or we could say that we could just write arc sine of 1/2. So there's the notation for inverse sine, and this means inverse sine also. Remember that inverse sine of x is not 1 over sine. So we know these points for the parent function, sine. And let's look at what we get with the points for arcsine. It's the inverse, so we know that the inverse, to do the inverse or find the points, we just switch the x and y values. And you're going to see that this is the wrong notation. We wouldn't get all of these values if we actually did arcsine. So let's just say it's the inverse relation. It's not the inverse function. The inverse function only has a few of these, but the inverse relation, we could say, has everything. So now let's look at the graph, and we'll see why we have to modify the y values. So there is the graph of sine, and let's look at the graph of its inverse. Zero, 0, 1. If we go over 1, we go up pi over 2. Here's pi over 2. Over 0, up pi. Over -1, up 3 pi over 2. And the graph would go on like that. So we wouldn't call this a function because it fails the vertical line test. So we just have to agree on a restricted range of inverse sine. We are going to just go from there to there. So if we graphed inverse sine we're only going to take that much of it. So that's the graph of inverse sine or arcsine. And let's do cosine. We'll have x equals cosine x, not x equals, we'll have x and cosine x over here. So that's going to be, let's just look at 0, pi over 2, and pi. And then for the graph of inverse cosine, we just switch those values. And so this is undefined. Negative pi over 4 will get negative 1, 0, 1, undefined. And so if we look at that over here, here we have a vertical asymptote, so that means over here we're going to have a horizontal asymptote at pi over 2. At the y value, pi over 2, we get a horizontal asymptote here and here. So the graph of inverse cosine will be from negative 1 to 1, and at 1 will be at 0. So that's what inverse cosine looks like. And inverse tangent, the y values will be from negative pi over 2 to pi over 2. And will be at 1 we're at pi over 4, negative 1 we're at negative pi over 4, and then there's a horizontal asymptote at pi over 2 and negative pi over 2. So that's what that graph looks like. And here's another way to look at to remember the restrictions on the range. So we have inverse sine, inverse tangent, and inverse cosecant. They will all have y values that go from negative pi over 2 to pi over 2. And the other functions, inverse cosine, inverse cotangent, inverse secant, they all have y values that will be here. The value of each inverse trig function is an angle, so it takes these angles from 0 to pi, and here we would have angles from negative pi over 2 to pi over 2. Another way to memorize these is cosine. This is cosine over sine and 1 over cosine. So they're all based on cosine. And here we have sine, sine over cosine, and 1 over sine. These are all based on sine. So sine gets the side, and cosine will get the top of the circle. So if we have arc sine radical 3 over 2, it means sine of some angle equals radical 3 over 2. And make sure it's a fraction. Then we can label it y over r and draw. We want all the angles that have a positive y value. So that's going to be this angle and this angle. We have the y value is radical 3, the radius is 2, and over here we don't know the x, we know the y. We don't know the x, we do know the y. So if we drew a triangle, we would see that that's a 1, 2, radical 3. If you don't have that memorized, you can do the Pythagorean theorem. So we know that that is going to be pi over 3. This is going to be 2 pi over 3, but we only keep the 1 on the side. So even though we do have a 2 pi over 3, the answer is just pi over 3. So maybe we should emphasize that we do have a 2 pi over 3 for this equation, but for this expression we throw that out because we have to restrict its range. Try that one. Pause the video. Y is 1, then y is positive, so we'll be here or here. We don't know the x. The y is 1. Radius is 2. If we look at the triangle, we have 1, 2, radical 3. So we know that that angle is a 30 or a 150. We could get a 30, I'll do it in radians, pi over 6 or 5 pi over 6. Since we're evaluating inverse sine, that's not an answer. That's not a value. Arc cosine means inverse cosine. So it tells us that we are trying to find an angle that has a cosine of 0. Make it a fraction, x over r. We want the angles that have an x value of 0, so that's going to be here and here. But cosine has the restriction that it only has values up here, so we know that this equation has solutions pi over 2 and 3 pi over 2, but since we're doing arc cosine, we don't use that one, so it's just pi over 2. Pause the video and try that one. So we copy it, make a fraction, label. We want angles that have an x value of -1 and a radius of 1, so that's going to be x value of -1 is here. and that's in the range. So we just want that part right there. Theta is pi. Pause the video and try that one. We want angles that have an x value, positive x value, so that's going to be on the right side. We can have an angle there or an angle there. If we label the x as radical 2 and the radius is 2, if you don't recognize these side lengths, you could just do the Pythagorean theorem and we'll get radical 2 there also. So it's isosceles, that means it's a pi over 4. Here we have pi over 4 and 7 pi over 4. But we can only take values on the top, so we don't use 7 pi over 4. And pause the video, try that one. Find the angle that has a tangent of 1, make it a fraction, label, draw. Here we have a positive number. Well, we could also have that's positive also. So we have over 1 up 1, and we go negative 1 down 1. We have these angles. If we look at this triangle, it's isosceles. It must be a pi over 4. So we could say it's pi over 4, and this would be 5 pi over 4. But for arctan, we can only keep numbers on this side, and that means we won't use that one. Pause the video and try that one. Read a fraction, label. We need angles that have a negative y value. So that's going to be here and here. Y is negative radical 3. We know that the x value is 1. Okay, there's a mistake here. We don't use this one because we have that. So we can have a negative y, positive x, positive y, negative x. If we have a negative x, we would be over here. And if we drew a triangle and it had the x is 1, the y is radical 3, that would be a 2. 1, 2, radical 3. So this angle is pi over 3. It's rotating down, so that'll be a negative pi over 3. We could say that this has 2 pi over 3 and 5 pi over 3. 2 pi over 3, 5 pi over 3. But neither one of those are in this range. We can't go beyond pi over 2. We can't, either way, we're going beyond pi over 2. So that means we need to go this way, and that's why these are not solutions, but negative pi over 3 Negative pi over 3 is a solution. All right, so if we just follow the same rules for transformations that we've been using, this will be pretty easy to do. Let's remember the points for the parent function. So inverse sine goes like this. And we also need to consider what's happening here. There's the function with 2x. So 2 is an inside change. That means we're going to do the inverse of what it's doing to x. So 2 times x, and that means we have to divide the x values by 2. This is -1, negative pi over 2, 0, 0, 1, pi over 2, and then we're going to have inverse sine of 2x. Divide the x values by 2. Okay, x value divided by 2, divided by 2, divided by 2. So it used to be starting at -1 with a domain of -1 to 1, and now it's going to be from -1/2 to 1/2. Y values stay the same. -1/2, we go to at -1/2, we go to negative pi over 2, -1/2, negative pi over 2, 0, 0, and we have that graph. All right, try this one. Remember that we have a new transformation here. We're multiplying the y value by 3 and dividing the x value by 1/2. Try that. And let's look at the graph of inverse tangent, or arctan. It has horizontal asymptotes, and these points so we have Let's just leave the x value blank, and we'll keep in mind that at the y value there's the asymptote. This will allow us to keep track of what's happening to that y value. Here we have this point, -1, negative pi over 4, and then we have this point, 0, 0. Then we have 1, pi over 4, and the asymptote at pi over 2. Since we're changing the y and changing the x, we can do it all at the same time. And let's multiply the y value by 3. And then we'll divide the x value by half, which means multiply by 2. Let's multiply by 2. So we're going out to -2, and asymptote is at 3 pi over 2, 3 pi over 4. So we still have that point. At 2 we go to 3 pi over 4. -2 we go to -3 pi over 4. There's the graph. One more with a horizontal shift. Alright, try that one. Pause the video. And the graph of inverse cosine is like this. It goes from 0 to pi, like that, and that's inverse cosine. So we want to use these points and then transform them with this. That's an inside change. That means it's horizontal, and we do the inverse of addition. We'll subtract 1 from all the x values. So we can look at parent function, -1 pi, 0 pi over 2, 1, 0. Add 1 to the x values. Zero to 2. So 0 pi, 1 pi over 2, 2, 0. So we get that graph. Oops. All right. I added 1, but we were supposed to subtract 1. So let's subtract 1. -1 minus 1, minus 1. We should have had a shift to the left. So now we'll be at -2, -1, So at -2 we go to pi, -2 to pi, -1 to pi over 2, 0, 0. Alright, and that'll do it.